All right, so we are in Chapter 1, Lesson 7 for IM1, and this is called Functions. So the first thing they go through and they jump into is function here. It says objective is to determine whether a relation is a function. Find function values. Those are our two objectives. So before we get too far here, I'm going to switch screens. I just want to review relations real quick. So this is the 4 ways to represent a relation. And remember, a relation is just a losing my train of thought here. It's just showing a link between two pieces of information. And I'm using the wrong wording here because I'm losing my train of thought. But it's literally just showing a relationship between the two pieces of information. So there's some kind of link between the two. If I plug in 1, this is what I get. So here's the ordered pairs: -2 and 2, -2 and -2, 0 and 1, 3 and 1. I can graph these, but I can also use a table. We use this really often, all the time. So we have X, Y, and they just have, here are my X's, here are my Y's. Keep in mind, this is also domain, and this is range. So it's another way you may hear of the X's and the Y's. Nicely when they're separated like this, it's pretty easy to see. And then we can also graph these pieces. So these are the four ordered pairs, or from the table. Here they are graphed. And then we also have a mapping. I like the map diagram because it shows us very quickly the difference between a relation and a function. So I can quickly see that if I have -2, so think of this like a machine when we want to function. If I put -2 in and I get -2 out of my machine, and then I put -2 in again and I get 2 out of my machine, something went wrong. If I put the same thing in, I should get the same thing out. So I shouldn't get 2 different values by putting in the same number. All right? So that's the difference between a relation and a function. A function, every time you put in an input, you should get a different output. And we can see that very easily. A visual way to see that is if I look at the graph here, I can see that these two are right above each other. So if I were to draw a line, a vertical line, and I can actually turn on my pen tool here, and this is called the vertical line test. So if I were to draw a vertical line straight down, and I know that's not super duper straight, but supposed to be the idea there. Oh, can I not see that menu option when I'm in full mode? Oh, I can't. Interesting. I didn't know you couldn't see that there. Oh, I think it's because I'm zoomed in. That's why. So when I draw that line straight down, and I can even use the grid lines here, it crosses both points. So that breaks the vertical line test. So that means that this is not a function because I can draw a vertical line through both. So when I'm looking at that, if I'm looking at a table, what I'm looking for is this issue here. I have -2, -2. So that means if I draw a vertical line, if I were to have a graph, I would cross this twice. I can have the Y value repeated. 1 and 1 here is not a problem because they're not above each other. So here's 0, 1, here's 3, 1. So I had to go 0, no left or right, and I went up 1. And then I went over 3 and up 1. This is still perfectly fine. This actually does not break function rules at all because if we had a graph, and this is not necessarily what this one would look like, but we do have graphs that look like this, and that's perfectly fine because they're not breaking any vertical line rules or the function rule there, the basic definition, where each input is going to have exactly one output. Here, I wanted to close that real quick. Okay. But I do like the mapping because it's very easy to see, okay, I can't have this -2 giving me 2 different numbers. All right, but I can have 0 giving me 1 and 3 giving me 1. That's perfectly fine. We just don't want to have them starting from the same point here. All right, let's go ahead. I'm going to close that and go back to my sketch pad here. All right, so function, a special type of relation that pairs each domain value with exactly one range value. So like I said on the other screen, domain is simply the X's and range is simply the Y's. Okay, put a little S after that. So it's the x values, the y values. That's all domain and range mean. It's just another name for those. So again, when I say exactly one, or each domain is paired with exactly one range, that means that if I put in 1 and I get 2, I should not be able to put in 1 and get another number. Again, that would mean my machine was broken, right? Think of it like a machine. I'm putting something in, I should get something very specific out. All right, discrete function, a function whose graph just has points that are not connected. So it's just, not necessarily random points, but just points, no connections there. And then a continuous function is those that graph in a line or a smooth curve. So usually we see a line like this, but we could see, some kind of curve along the lines like that, some kind of nice curve. We can clearly see functions if we graph them and apply the vertical line test. So like I was talking about, if I were to draw a vertical line, and we can even see the y is a vertical line here, right? So we have a vertical line there. But I can draw a vertical line anywhere I want on this graph, and it's, as long as I don't curve it, it's not going to cross the any point of that graph more than once. So that's how it breaks the rules, if it crosses it more than once. So if I take this one, the only thing that I can draw that only crosses it once is that y-axis. Again, if I can draw straight down there. There we go. So it crosses it at just the one point there. But if I draw it anywhere else, crosses, 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 crosses. So it doesn't matter where I draw the lines, it's going to cross 2 times. Okay? As soon as it crosses more than once, it is not a function. That means that we have a repeated domain or x value. All right? So down here, we're just looking at the difference between the two, and I'm going to come back over here in just a second. So this is actually defining this piece here. So we have function notation. So we read function notation in this way. F and x in parentheses, we say f of x. If it's h, then we say h of x. So that's how we read function notation. And what that means is down here I have this equation that says y equals 3x minus 8. This is how we've been used to looking at it. But the function notation actually means the same thing. So now we have f of x equals 3x minus 8. If you notice, the only thing that changed was y changed to f of x. So we're just turning this into function notation. Remember, f of x or h of x or whatever letter they're using, it doesn't matter what letter's in front here. It's just different functions, or an indication of different functions is all that means. So whatever letter's in front, in this case, f of x, it's the same idea as y. We solve it the same way we would a normal equation. All right. It's just a specific notation for functions. X values represent the domain and of the function, and f of x values are the range. So again, same idea as I set up here. We have the x values of the domain, but now instead of y values being the domain, it's what we get for f of x. So what this equals when we plug things into it. All right, let's go ahead and take a look at a practice problem here so that we can kind of see this a little clearer, I think. So we have, you can find range values by simply plugging in domain values. Again, range is the y or the f, that's supposed to say or of f of x, or whatever letter it is. In this case, it's h actually. Domain value are the x's, all right? So if they say find h of 4 for h of t, what they want us to do is the 4 is in the place of this t. They want us to plug, wherever we see t, they want us to plug in 4. That's what they're asking us to do here. That's what this notation means. So down here we can see, here's f of 4, h of 4, equals negative 16 times 4 squared. So instead of t squared, I plugged in 4 here. And then plus 68 times 4. So instead of t here, I've plugged in 4. And then plus 2 in the end. So now they're going to go through and start simplifying. Here's 4 squared, that's 16. And then the next step, they haven't simplified anything else. They just brought everything else down. So the next step, they actually start multiplying. Negative 16 times 16 gives us negative 256. 68 times 4 gives us 272. Started saying that backwards. And then plus 2 gets brought down. Now, we can just do our addition and subtraction. So when we subtract and then add, we get 18. So if I plug in 4, that's my input, that's my x. So my domain in this case would be 4. My range would be 18. And I can keep going. So, domain and range usually refer to a set of numbers, not just the single answers there. But this can also be a coordinate for 18, like this. Here's my x, here's my y. Again, the function notation, what it equals, h of 4 equals 18. 4 is my x, my input. 18 is my output. That's what I get when I put in 4. So with this one, the basic idea there, I know I went through it a little quickly, but the basic idea is we're following the order of operations. So always follow the order of operations when you're doing this. So parentheses, then exponents, multiplication or division from left to right, addition or subtraction from left to right. All right, so let's go ahead and take a look at these examples down below here. We have determine if these relations are functions. So remember, they're telling us the relations. The numbers have some kind of relationship to them, but we want to know, are they actually a function? So we want to look at the x's here. So I have -2 and I get 1. I have -1 and I get 2. 0 and I get 3. 1 and I get 4. So they are all different. The domains, the x's are all different. Every time I have one input, I get its own output. So this would be yes, simply because for every input, I have each input, or each domain, I'll say it the way they have it up here, value with exactly one range value. All right, now part B, I have 1, 1, 1, 1. This is a problem. 1 is being repeated. So if I put 1 into my machine, I get 3. The second time I put 1 in, I get 0. The third time I put 1 in, I get -2. The fourth time I put 1 in, I get 8. This machine is very broken. It should not be giving me 4 different answers if I put in the exact same thing. So this is definitely a no, because our x values are repeated. And again, if we were to graph these, if we were actually look at a table, or not table, I'm sorry, a coordinate grid, and we were to graph these, part A here would not break the vertical line test, which is the easiest visual way to see that. B would definitely break the vertical line test because they would all be straight up and down in a line. All right, so that's just the kind of basic idea of identifying it here. And it shouldn't matter if it gives it to you as coordinates like this, it gives it to you in a table, if it gives you a graph, or if it gives you a mapping. What you're looking for is, did I repeat the x values? If an x value is repeated and you get a different y value, your machine is broken. It's a very silly kind of relationship there, or not relationship, but the way I'm defining it. But that's kind of the way I like to define functions, is they are a machine. All right, so now we're going to look at the second part here, and it says, find these values for f of t equals 2t cubed. So they want us to do, these are two different problems. We're going to have two different solutions. So we want f of 4. So we're going to plug 4 in for t. So 2, instead of t, I'm going to write 4 cubed. And I'm going to, really quick, open my calculator because I wanted to make sure everybody knows this. So when you're doing exponents, this is on my computer, but this should be the exact same idea when you're looking at your phone. So you should be able to flip this. If you flip your phone sideways, you should see something along these lines. So if I wanted to do 4 cubed, I could go 4 times 4. So that's squared. It would give me this. I could actually hit equals again. It's going to assume I want to multiply by 4, and it'll tell me it's 64. But I can also do 4. So if I go back, my base is 4, and usually calculators will at least have a squared, but many of them have a cubed. I can click this button and it will cube it for me. If yours does not have a cube, you type in your base and then you look for this symbol here, x to the base of x raised to the exponent of y. What this means is x is the number that you type in first. This is your displayed value. When you hover over this, it'll actually tell you raise raise the displayed value to the power of the next value entered. So what it means, the displayed value is your base. In this case, it's 4. And then I could click this button. Doesn't do anything yet because now I have to tell it what the y is. What is my exponent? It would be a 3. Again, this is not my answer. I have to hit equals. So it's just a couple of ways we can use calculators to help us. Cubed is not really a difficult one. We can definitely do that one, without a calculator if we needed to. But once we start getting bigger exponents, this is definitely a convenient tool on our calculator. So let me go back to Sketchpad here. So we would have f of 4 equals 2 times 64. So now we can do our multiplication here. So f of 4, pen tool's kind of messing up there as I write. We want to multiply, so we'd have 8 and 12. So I just went ahead and multiplied kind of in my head there. So 2 times 4 is 8, 2 times 6 is 12. There we go. We have our 128. You could also do 64 plus 64 in your head. It just depends on that one, how you would do that one. Or you could write it off to the side. You can use a calculator, but this one's not too terribly hard to do without a calculator. All right, so if we plug in 4, we get 128. Now we're going to do -5. So it's going to equal 2 times -5 cubed. So f of -5 equals 2 times, and again, I'll show you this. So now our base is 5, but it's negative. So when I have a negative, I can click this little plus minus sign and it'll put the negative on there for me. So here's my displayed value, or my base, because displayed value is the way that the calculator refers to it. I can click the cube button and that'll cube it for me. And remember, this is -5 times -5 times -5. So it's still negative. There's 3 negatives in there. So 2 of them cancel out to be positive, but then we have a third one that makes our answer negative again. And that would be 125 if I do 5 times 5 times 5. If your calculator does not have this cubed button, you still type in the -5 like this. And it'll probably be something along these lines. Not all of them have this little toggle. Sometimes it looks a little different, but it should look something along these lines. You hit this little button, tell it your exponent is 3, and then hit equals, and you'll still get the same answer. So it just depends. Most calculators, I think the scientific ones, have this button for the cube, but if they don't have it, they should have something along these lines where you can tell it what you want your exponent to be. I think I was maximized there. So there we go. So we have -125, is it 2? And then f of -5, we get, so 2 negatives, or not 2 negatives, sorry, 2 times -125. We're going to have negative, and then we just want to multiply this out. So I know 25 plus 25 is 50, 100 plus 100 is 200, so 250. So I can do that mental math kind of quickly if I look at it that way. You could actually write it out here if you wanted to, where you're multiplying, or you could do 125 plus 125, if you wanted to write it out so you could see. So it's just two ways to do the same thing, or we could use a calculator if we needed to. But again, this one's not too terribly crazy to do without a calculator. All right, so that was section 7, and I will see you in section 8.